Like how? Would you like to do the drawing?
Like a tangent.
Like a tangent. So it doesn't necessarily have to be the vertex. And that's another case of one solution. So I'm going to draw a parabola like this. And then maybe it just touches that point. Okay? Only one point. Now, it doesn't have to cross so that we can call it an intersection. Okay? The fact that there's a point that is shared by both the parabola and the line means an intersection. Okay? So one solution could happen like this, crossing the parabola, and another case of one solution could happen with the line being a tangent line. So it's just going to touch once. Now we're still missing one more case. Which one is it? When?
The line doesn't touch.
When the line doesn't touch? Okay? Yeah, you go, yeah. It sounded so obvious, no? But nobody said it. Something like that. Okay? We have a parabola, so of course it could be opening downward or upward, but then the line is far away or maybe close by, but it doesn't touch the parabola. Okay? So when we try to solve this, we're going to get to, for example, and we're going to see it with examples, we're going to get to the solution of a quadratic in which we will get complex numbers as solutions. Okay, we're not going to have real solutions. Real solutions would mean a real intersection, a real point of coincidence, but imaginary or complex solutions would mean they do not meet at all. Okay? So here we have no real solutions. I'm going to write it like that. Because we are going to have solutions, but they're not going to be real. Okay? Real solutions will mean that we have one or maybe two intersections.
So quadratic are the ones like it's a parabola and like a linear one?
Yes.
Okay.
Mm-hmm. So we have a system. That means that we have two or more equations in which one is quadratic and one is linear. And we can have all of these four cases. Okay? Two intersections, one solution crossing, one solution tangent line, just touches one point, and no real solutions when the line is somewhere and the parabola is somewhere else. Okay? So I have these, we're going to do a couple of examples, okay, so that you can, and this will give us the opportunity to practice a little bit about solving quadratics. And then we're going to confirm them by looking at the screen and the graphing program. By the way, I have told you this many times before, and I hope that somebody will listen to me. And what I mean is that, of course, you're not allowed to bring a computer to the exam, okay? But when you are practicing, you're going to take maybe, and I think it's too much what I'm going to say, I think you're going to take 30 seconds, no? In punching in the equation or the intersection point, and then you will be able to confirm that what you got analytically is correct. And that will build up your confidence, okay? Like you will say, well, yeah, I can do it, and I got the right answer and all that, and then I can confirm it. So then when you get to the exam, you will be able to do it feeling more confident. So there are several options, and they're all free, okay? You can download them, they're freeware. So one is, GeoGebra. Okay, I think it's .org. I already told you about that one. There's another one called Graphmatica. I think that's .com. And then if you have a Mac, then there's this program called Grapher. Okay, that's one of the utilities or whatever you call it inside the Mac. That's already installed program. You don't have to buy it or anything. Okay, so any of those are very good choices. And of course, you have to practice. Maybe read the tutorial or online manual or whatever a little bit, so you know how to use it. Okay. So we're going to see two examples, and then after that, you're going to start working on some that I brought for you. Okay? Now, remember, we're not going to do... Where did we have the... Let me turn it on. Okay, yeah. I'm going to move it to the right, so we have this space for the screen to show. Okay, I'm gonna do it like over here. Okay? So, one way to do it, of course, is by substituting. The other way to do it is by equaling, no? And, yeah, not equalation, equaling. Okay? So, here we have exactly this case. Okay? We have one quadratic function, we have one linear function. Now, right now, because it's let's say it's beyond the scope of this course. Right now, we are going to focus on doing the solution analytically. But we're going to use the program just to check that our answer matches what the program says. Okay, and then we'll be sure that we did it correctly. Okay, so I think in this case, it's ready for equaling. No? Someone said what? Factoring?
The first one.
Yeah, okay, well, the first one can be factored. But right now, that's not the point. We're not going to factor. And in fact, it can't. No? It looks a lot like a perfect square. Except for what? This one should be positive. Right? If this one's negative, there's no way we can factor that into a square binomial. Okay? But, well, it looked a lot like it. No? Like wishful thinking. Oh, we wish it was a perfect square, but it isn't. Okay, so we can, let's name this one 1 and this one 2. So we will do 1 equals 2. And we have x squared minus 2x minus 1 has to be equal to x minus 1. Okay? Now, what would you try as a first option to solve that?
To pass x minus 1.
To send everything to one side. Now, do you agree that I can cancel out these negative ones?
Yes.
Because we have them both, they're the same and they're on opposite sides of the equality. Okay? And then we can send this x as a negative x to the other side. We will have x squared minus 3x equals 0. Okay? Now, that is one type of quadratic equation which is not a complete quadratic equation. It's a quadratic equation. It's lacking. It doesn't have the independent term. So what would be the best choice? Would you use, factoring. Okay? So how do we factor this?
X squared is equal to 3x.
X squared, no?
X
times x minus 3.
Okay.
Okay, so what we have is a common factor which is x. We pull it out. And, of course, we could check it very quickly. X times x is x squared. X times minus 3, we got negative 3x. Okay? So we have two solutions. One solution is x equals 0. The other solution is x equals 3. Okay? Now, is that a point?
Yes, if that's 0, no, it's only about the
That's the coordinate.
no,
Is that the full coordinate? No. This is half a coordinate, and this is half of the other coordinate. So I'm guessing that a very common mistake could be to go back to linear equations, linear systems, and then say that the solution is 0, 3. I mean, I think it could be a very common mistake, so you have to watch out for that. So, if we have arrived at two different values of x, what does that mean in terms of the different types of solutions that we can have?
that you will have.
That we have two solutions, that it's a parabola that's being crossed twice by the line. And we're going to confirm it with technology. Okay? Now, how do we find the y that corresponds to this x? We can substitute, and I would substitute in the easier one. Okay? In this case, I would substitute in equation 2. So y for this one is going to be 0 minus 1. So y equals minus 1. Now, are we ready to write a coordinate now? Yes. Well, first one. So the first coordinate is 0, negative 1. Okay? Now, second solution, second coordinate. If we substitute 3 in the same equation, okay, we're going to get 3, that's the x, minus 1, so y equals 2. So, the coordinate is going to be 3, 2. Okay? Yes?
what about dx squared minus